Hello everybody. In this lecture I am going to solve a beautiful geometry problem. In this problem we are given the triangle ABC with AB greater than AC and the extension of the altitude AD with D lying inside BC intersect the circumcircle omega of the triangle ABC at point P. And the circle through P and tangent to BC at D intersect omega at Q distinct from P with PQ equals to DQ, and we have to prove that AD equals to BD minus GC. Okay, fine. Okay, first we have to draw a diagram. In the triangle ABC, the side length AB is greater than AC. Okay. Something like that. We take this top vertex as A, this is B, and C, then definitely AB looks like greater than AC. And now the extension of the altitude AD with D lying inside BC intersects circumcircle omega. Okay, omega is the circumcircle of this triangle ABC. So first draw the circumcircle of the triangle ABC. Something like that, and we are given that if we draw the altitude AD and if we extend this altitude, then this altitude intersect the circumcircle whose name is omega at point P. Okay, at point P. The circle through P and tangent to, okay, this point of intersection is D. This point of intersection is D. Okay. And now we are given that the circle through P and tangent to BC at D intersect omega at Q. Now we have to draw another circle which touches the side BC at point D, passes through P and intersect omega at another point Q. Okay, let us draw the second circle which touches BC at D, passes through P. Something like that. Actually this circle touches BC at point D, that is BC becomes the tangent to the second circle and this second point of intersection is Q. Okay, and that's going fine. We are given that PQ equals to DQ. PQ, okay, DQ and PQ are of equivalent. This equals to this. And we have to show this result. Okay. My first observation is for the second circle. For the second circle, line BC is tangent and line AP is perpendicular to this tangent. And if this line perpendicular to the tangent, then definitely the center of the second circle will lie on the line DP. Definitely the center of circle lies around this. And we call the second center of second circle is O2. O2 is because the center of a circle we take as O1. Okay. Therefore, there is advantage. If PD is the diameter of the second circle, then definitely this angle is what? This angle is 90 degree. Okay. And if we extend QD, then it will intersect the first circle at point say something like A, B, C, D, say something at M. Okay, no problem. Okay, now this angle is 90 degree, and therefore if we join point P to the point M, then we get very interesting result. Because this angle is 90 degree, therefore PM becomes the diameter of the first circle, and if PM becomes the diameter, then definitely the center of the first circle lies on PM. Okay, center of the first circle lies on PM, and if we join A to the point M, if we join AM then definitely this angle MAP, this angle is 90 degree because PM becomes the diameter of the first circle. Therefore, this angle is 90 degree. And if angle PAM, since angle angle PAM is 90 degree, this will implies AM goes parallel to BC, and if AM goes parallel to BC, then definitely this quadrilateral, then quadrilateral BCAM becomes an isosceles trapezoid. Definitely, this quadrilateral becomes an isosceles trapezoid. Okay. The advantage of this result is what? If we draw perpendicular from M to the side BC, and suppose this foot of perpendicular is N, this foot of perpendicular is N, then what we can write? This distance Bn, because this quadrilateral is isosceles trapezoid, therefore definitely Bn is what? CD. Then Bn equals to CD. Okay, what we have to show? BD minus DC is equals to AD. Now, BD minus DC is what? BD means what? Bn plus Dn minus CD. But we already proved that Bn equals to CD. Therefore, this and this cancel out. What we get? Dn. BD minus DC is equals to Dn. Okay. Also, this angle is what? This angle is 90 degree and these two side lengths are equal. It means that these two interior angles are both 45 degree. And if this angle is 45, then vertically opposite angles are equal. This angle is also 45. Here the quadrilateral AD and NM looks like a rectangle. In the first look, this quadrilateral looks like a rectangle, but this rectangle has a special property. Its diagonal bisect the interior angle. It means that this rectangle becomes a square. This is a property of a square because if the diagonal bisect interior angle in a rectangle, then that rectangle becomes a square. And if ADNM becomes a square, then these two side lengths, then adjacent side DN and AD are equal. Then what we can write? DN equals to AD. The reason very much clear because we have proved that this rectangle ADNM becomes a square. Therefore, adjacent side length are of equal length. Therefore, what we have proved that BD minus DC equals to AD. Hence, we are done. Thanks for watching.